So this is what the classification. Just now we have seen in the previous video, we have seen some different classification of classes A, B, C, D and E, and by seeing the first portion we can identify which class that particular IP address belongs. So based on that we can differentiate which address belongs to which class by seeing the first portion of address. So let's try to get into some more in detail. Like we discussed that there are three classes: class A, class B, class C, class D and class E. And also we discussed that 0 to 127 belongs to A class, 128 to 191 belongs to B class, 192 to 223 belongs to C class, and 240 to 230, 24, 239 belongs to class D, and 240 to 200 belongs to class E. In these five classes, they said that these first three classes we use for LAN and WAN, which means in practical we use only three classes. We use class A, we use class B and we use class C, whereas class D is reserved for multicasting, so for generating multicast traffic, and class C they reserved for research and development. Generally even the people call it as a future use. So for research and development, for testing purpose, they reserve class E. Like to understand multicasting, let me just try to figure out the different types of communication in general we have. In general, in our network, we got three different types of communications. We got unicast, we got broadcast, and we got multicast. So we got mainly three types of communications. Unicast, where we say one-to-one communication. In general, one-to-one means in case if you have a network like this, you have a network where you got some multiple computers connected in the LAN. So we got some multiple devices connected in my LAN, and in these multiple devices, one device is sending a request to one device and the other device is replying, and we call this type of communication as a unicast communication, which is the default communication happens in most cases. Like if you take an example of internet, by sitting here I'm sending a request to yahoo.com, and the Yahoo server is going to reply to me from internet. Anyway, we are connecting to internet in the LAN, connecting to router, and router is connecting to ISP connecting to internet. Maybe there are many devices, but your request mostly goes as a unicast packet depending upon. Okay, so mostly it is a unicast type of communication. Unicast is the default type of communication which happens in most of the networks, where one device sends a request and the other device responds to the request. So whereas generally we call as one to all. So broadcast is the second type of communication which happens in our network, and with broadcast we call as one to everyone. Like I got 200 devices connected in my LAN, so one device generates a broadcast. The broadcast goes to remaining 199 devices, means it goes to everyone. So like there are some broadcast addresses, like example I can say there is a universal broadcast address we call as 255.255.255.255. So ping messages, ping is generally used for testing the connectivity. If I try to send this address to, if I send a ping message to this address, it will try to get a reply from all the devices. So let me just try if it works in my PC. I'm connecting to internet. You can see it's CMD. I'm trying to ping. Already I have my own IP addressing. I'm already using some IP address, something 192.168.1.3, which is assigned by my router, which is I'm using for internet. So I'm trying to ping, just trying to ping to these devices. I'm not sure whether I have, please check that I'm trying, and so it's not pinging actually in general. So I think I can get a reply from 1.3, which is my local PC. So there's no other PC connected in here in my network. Probably I think 1.1 I can get a reply, because 1.1 is my router address, the router which I'm connecting to my internet. And if I ping to the last address, then there's a broadcast ID. If I try to ping to this broadcast address, so we'll get a reply from all the devices. So I'm not getting exactly here. So generally there are some addresses called broadcast address, where we'll see this broadcast address here. This is something called broadcast ID in our IP addressing. So generally we call this as broadcast addresses. So broadcast is a type of communication where we are sending the information to everyone. To everyone we are broadcasting. Switches will do broadcasts in general. So unicast, normal communication. So there is one more type of communication we call that as a multicast, where we are trying to send to a specific group of addresses. Like maybe I have 100 devices connected in my LAN, but I'm just sending it to only respective devices. Like I'm sending a request only to 10 devices, not for all the 100 devices. So multicasting, we can say some examples like all your video conferencing applications, the video conferencing applications, or even we can say on online videos, online audio, and some live streaming of any match. So probably these are all the examples of multicast traffic. And to generate and to host that type of multicast traffics, they use this address. So this address is going to identify the group, and whichever the group want that multicast traffic. So multicasting is something far beyond the concept of our CCNA. It's a little bit advanced topics, so we don't get into that much in detail, but I'm just giving you some idea if you want to generate this type of traffic. So we use this range. So probably this address range we don't use in our LAN and WAN. Even if you try to give, the device will not accept. I can show you there. Like I go to TCP/IP here. If I go to my properties, and if I try to assign some address like 224, when I try to type 224, you can see it is saying it's not a valid entry. Please specify the values only in between 1 and 223. So because one is your here you can see 0 is not valid again. So one is A class, 223 is the last address of C class. So anything beyond that you cannot use in any network, so it will not accept. But you can use the remaining addresses till 255, because the first portion only differentiate the class. Okay, so as per this, we can easily understand that okay, we don't use class D, and even we cannot use class E also, because it is reserved for R&D research. For testing purpose they reserve this address range, so we don't use class D and class E. So when you talk about network, we only use class A, class B, class C. So this is one of the reasons why they classified. Just they want to make sure that they have a separate addresses for research and development, and then separate addressing for multicasting, and also for LAN and WAN. And for LAN and WAN again, let us get into some more in detail about these first three classes which we use. So here we will be discussing about class A, class B, class C, which are generally used in the LAN and the WAN purpose. And just now we discussed that 0 to 127 comes in between A class, 128 to 191 belongs to B class, 192 to 223 belongs to C class here. So now again these three classes are further divided into some portions. Like we know that there are 4 portions. If I say 192.168.10.10, we got 4 portions. Each and every portion represents 8 bits. So like that we got 2 portions, 3 portions, and 4 portions. So these 4 portions again further divided into 2 parts, like network part, and network part, and then there is host part. So host. So in general in A class there is 1 network portion and 3 host portions. In case of B class, 2 network and 2 host. In case of C class, 3 network and 1 host. So let's try to understand what is exactly these network and host portions. So network and host portions are similar to your hotel room numbers. Generally, if you just take a real example like hotel room numbers or any flat numbers, in general the numbering will be something like this: 102, 103, 104, 105, something like this. Again we can say 201, 202, 210, 212, and similar way here 312, 313, something like this. So if you just try to understand this addressing, whenever we see 33313, something like this, we'll see the first portion which is common. Generally that represents, mostly it will be the floor. So whenever I say 313 means I'll understand okay, it is on the 3rd floor, and on the particular third floor I got 13th room number. This is what identifies room number. Okay, so that is what we generally understand. So by seeing this also we can understand this part is just like your floor number represents the floor, and the remaining numbers mostly represents your particular room number. So similar way here also we can compare this floor part as a network, and the room part we can compare just like a host. So room means individual room, and those group of rooms are grouped together and referred as one common floor. So similar way here also, if I take a similar example here in my, if I just take a similar example here, let me just try to take some example. Okay. Fine. So if I just take an example here of same thing, like here we got two types of portions, host, network. Now here the host represents a single device in network. Generally a single device in the network is represented as a host. Means it can be any computer, it can be computers in the LAN, or it can be any other device like so let's take an example here. So host represents a single device in the network, one single device. If you talk about a LAN here, in my LAN I can have 10 devices, and each and every device represents one host. It can be computer, it can be a router, it can be a firewall, any device, any one single device we can represent, we can call it as a host. Whereas network, set of devices. Generally network represents set of devices, or grouping all together we call as network. Okay, so now, so here similar way here, like we can say network and host is similar to, host part is similar to your room number. In the previous example, network part is just like your a specific one floor which has multiple rooms. So but here if I take one more example, like if I say if I take the example of our floor and room numbers, if I ask you 401 and if I ask you 302, so do they belong to the same floors? So now the answer is simple, they are not on the same floor, they are different floors, because this first number represents 4, which is on the 4th floor, and the second number represents 3, which is on the 3rd floor. So 4th floor, 3rd floor cannot be on the same, right? They are different floors and different networks. Similar way here also, whenever we are understanding the basic IP addressing, so like take an example, I got one device with an IP address of 192.168.10.10. Let's say the IP address of this device, and I got another device with the IP address of 192.168.5.10, something like this. So maybe you can assume the IP address of the another device here. So my question is here, will these two devices will be able to communicate or not? So will they able to communicate? So the answer is they will not be able to communicate between them, because they are logically, even though they are physically on the same network, physically means physically when you connect, they are both in the same LAN, physically they are in the same network, but they are logically, we call them, they are in different networks, and they cannot communicate, because whenever you see any address, first you have to identify the class, which class this IP address belongs. So if you remember the range 0 to 127 is A class, 128 to 191 is B class, and 192 to 223 is your C class address. So now 192 comes in between C class. So in case of C class, if you remember, we already discussed in our previous example, C class contains 3 network portions. This is our C class, which contains 3 network portions and 1 host portion. So in my case also, in my example, if you take this example here, It's a C class, so C class contains one network, two network, three network, and there is one host portion. So in order to win the same network portion has to be same. So in my example, the first three portion has to be mandatory same in order to communicate. So in this case, 192 is same, 168 same, but the third portion is not same. So in order to win the same network, the first three portion has to be same. Then only we call them as same networks. So which means they will be considered as logically different networks because they have different network portions. Just like, 301 and 401. They are not on the same floors. They are logically different networks, different floors, because the one is third floor, the other one is fourth floor. Similar way here also, they are different networks, and by default different networks cannot communicate unless and until you have a router. And if I want these two to communicate, then you need to have a router and you have to do some routing, and based on that they can communicate. So but by default they cannot communicate. So this is the very important logic we need to keep in mind when we design any networks. So now we need to understand what is the requirement. As per the requirement, you need to decide whether they should be in the same network, whether they should be in different networks. If they want to be in the same network, then you have to make sure that network portion has to be same. So network portion in case of A class, if you are using any A class address, you have to make sure that first portion should be same, mandatory. And if you're using B class, you should have two network portion has to be same, mandatory. In case of C class, the three portion has to be same in order to have a proper communication. If they are not same, then definitely they will never communicate with each other, because if they are not same, they will be considered logically different networks, and different networks will never communicate unless and until you have a router and routing process involved in doing that. Okay, so these are the very important guidelines which you have to keep in mind whenever we are designing any networks. So let's try to add some more examples here, just for having some enough practice. So I'll take one more example. 210.10.10.10 is the IP address of one device. Now I want you to just try to understand whether they are in the same network or different network. 210.10.15.10. So my question is, physically they are connected on the same LAN. There is no problem in the connectivity. Both the devices are powered on. My question is, will they able to communicate or not? So simple. You have to first identify the class. 210 comes in the range of 192 to 223, which is a C class address. So it's a C class address. In C class there are three network portions. In order to be in the same network portion has to be same, but here they are not same, and we consider them as to be on different networks. So they will never communicate. Similar way, if I take one more example, let's write down 150.12.10.10, one device, and another device 150.12.15.15. Now the question is same. Do they belong to same network? Will they able to communicate? Now the question is that, and the answer is yes, because 150 comes in the B class. So in the B class there are two network portions and two host portions. So in order to be in the same network portion should be same. In this case, they are on the same networks and they will communicate with each other without any problem. So probably you can try this practically. You can verify this behavior by, if you have some two computers, like you have a PC and a laptop, you can connect into a cross cable, and you can try to assign the IP address on one side at 192.168.1.1 and the other side 192.168.2.1. They will never communicate, and you can try to ping from this side, ping to the other end of the IP address 2.1. They will never communicate because they are on different networks. So once I change the IP address to 192.168.1.2 on the other side, now it will start communicating because they are on the same networks. So it's good to have some more practical verification of these things if you want to get into some good understanding. But still, this will ensure that these examples will ensure that you have a very good understanding on these things. Let's move on with the last example. So I'll add one address with 100.10.10.10 and 100.15.15.15. So now the question is same. Do they belong to same networks or different networks? Identify the class, So these two addresses belongs to A class. So in the A class there is only one network portion, and in order to be in the same network, that one portion has to be same. So which means they are on the same network and they can communicate with each other without any router. So by default they can communicate. So the first thing we need to have a very good understanding on, we should be able to differentiate the class, which class that IP address belong. It is A class, B class, C class. And the second thing we need to understand remember the different portions we have. In A class there is one network portion and three host portions. In the B class there are two network and two hosts, and in the C class we got three network portions and one host portion. So once we have some understanding on these things, probably we can okay. Next thing is, let's take one simple scenario to understand more in detail on the designing, because this is something which is very important whenever you're designing any networks. These are the important points we need to keep in mind. Okay, so let's take an example. I got my company. Let's say I'm the administrator of any organization. I got a requirement of 200 devices connected in my LAN, and all these 200 devices are already connected in the LAN. Physical connection is perfect. There's no problem. All the devices are connected to the LAN through switches. Maybe you're using more than one switch. So all are connected. Physical connection is perfect, but simply connecting them physically will not help you, because once you provide the physical connection, the second step, this is the first step anyway, all the devices interconnection should be perfect. And the second thing, we need to give a unique address for each and every device. So that's what we call as IP address. So whenever we are designing this, and you need to first identify the requirement. Now the requirement is, my manager wants all the 200 devices should be on the same network. Same network means they should be able to communicate. Physically anyway they are same networks. Physically they are on the same networks. That's not a problem, but I want to make sure that these devices should also be logically same. They should physically same, and I want them to be logically same as well. So now when we're designing this, when you are doing these things, the first thing we need to keep in mind, which class you want to use, whether you want to use B class, A class, or whether you want to use C class. So ABC, any of these three classes we can use. Let's say I decided to go with a C class address. So now the question is very clear. You have to make sure that all the devices should be on the same network. So which means, same network means, so whenever you are deciding that should be in the same network, means, let's say I'm using 192.168.10. network, suppose something, and we will know that C class contains three network portions, and in order to be in the same network portion has to be same, mandatory, which means I have to make sure that this 192.168.10, 192.168.10 remains the same till the end. I should not change. If we change this number, any of these three numbers, it becomes different networks, which I really don't want, because as per my requirement, I want them to be in the same network. Any three portions you can use, it's up to you. So probably I can play with the last portion, that is the host portion. I can start with 0, I can give 1 for the next device, I can give 2 for the next device, 3, 4, like that. I can go up to maximum of 255, because in IP addressing I cannot go beyond 255. That's the last number. So which means if you just count total addresses I get 256, because you are starting from 0 till 255. Okay, so in a C class network I get how many addresses in one network? In one network I get around 256 addresses. So which means if you have a requirement of 200 to 250, in between around that, or anything less than that, probably C class is more applicable. So C class supports 256 addresses in general. So that's what I wrote here. You can see the table here. It supports around 126 networks, here, and each network supports 256. Actually it's 256. So there is a -2 here. So -2, I'll come to that point. for network ID and the broadcast ID, but in general there is 256 addresses it supports. But now, if your requirement, maybe my manager says that okay, so don't go with C class because C class only support 256 addresses. Maybe in the future, maybe in the next couple of years, we are going to add 200 more devices in the LAN. So when you add 200 more means it goes to 400. So which means 400 devices a C class network does not support in one network. So probably you need to use multiple networks. So my manager says not to go with the C class. So that's the reason what I did. I tried to go with B class. So I'm not planning for C class. Maybe I'm just trying to go with any B class address. So when you talk about any B class address, any B class, let's say I'm using 197.16 and B class, there are two network portions. And in order to be in the same network, you have to make sure that 172.16 should remain the same till the end. End means it should not change. If it changes, it becomes different network. So I can only play with the last two portions, which are my host portions. So probably I can start with 0.0, first number, 0.1, 0.2, like that I can go up to 0.255. So I can go only up to 255 because 255 is the last maximum number in IP addressing. So after this, we can continue with 1.0 because once you finish this 0.x, probably you can start with 1.x. 1.x means x represents any number from 0 to 255. So I can say 1.1, 1.2, I can go till 1.255. And once I finish 1.x, I can start with 2.x, 3.x, 4.x, like that I can go up to maximum of 172.16, 255, 255. So this is the maximum number I can use till this part. So if you just count down the total number of addresses, it goes around 256 addresses. We are adding 256 times. So it goes around 65,536 addresses. So this is the main reason again for classification, because in order to meet different size requirements, they made multiple classes and multiple portions also vary, because here you can see there is only one host portion and one host portion represents only 8 bits, which means we can only change this one portion. 2 power 8, 256 is the size of the network. If you see B class, 2 host portions, which means total 16 bits host, 2 to the power of 16, it goes around 65,536. Similarly, if you take the example of A class, you get 16 million addresses in one network. It's a very big number actually. So similar way, you can just think about A class as well. So similar way, if I talk about any A class, I have to make sure that first portion should be same, 10 should be same till the end, and I can change from 000, I can go to 001, just like 255. And once you finish this portion, you can continue with 0.1.0, and I can go to till 0.1.255, like that I can go to till 0.255, 255. And once I finish this portion, I can just move on with 1.00. So in place of this, again you have to write 1 and you have to finish till this part 1. Similar way 2, 3, like that till you get 10.255, 255, 255. So which means you get 256 cube addresses. It goes more than 16 million addresses. So the exact number is 16777,216 is the exact number. So anyway, just we need to have an idea which class supports how many addresses. So as per our examples here, a C class network supports this many addresses here. C class network supports these many addresses. B class supports 65,000 addresses. And if you run different network combinations, starting from 128 to 191, you get more than 16,000 networks. And each network supports around 65,536 addresses. -2 we need to do for network ID and the broadcast ID. Okay, so like that. So this is how they made the main reason for classification is to meet different size requirements. So some companies, some organizations may have just a 200 users. They can go with any C class example. Either they can use B class or A class also, but C class will be enough for them because C class supports 256 addresses in one network. If something beyond that, like if you have a requirement of 500, 1000, you can go with any B class or A class addresses. So to meet different size requirements, they use different classes. Okay, so